Hi, here are the answers to the Chapter 8 test. I've got the multiple choice questions here, and remember that these questions are probably not in the same order as the form that you took. So the questions are the same, they're just not in the same place as before. So for question 1, which of the following counts would a binomial probability model be reasonable? We have to look for the situation where the four characteristics are true. So we have success or failure. We have the probability of success is the same, the probabilities are independent from trial to trial, and a fixed number of trials. So A is not going to work because there's no fixed number of trials. So A is out. B, the number of hearts in a hand of 5 cards dealt from a standard deck of 52 cards. The problem with that is the probabilities aren't the same because they're not independent as you start pulling cards out. So that doesn't work. Obviously all of the above is not going to work either. Number of phone calls received in a 1-hour period won't work because there's not a fixed number of trials. So the answer has to be C, the number of 7s in a randomly selected set of 5 random digits from a table of random digits there. That exhibits all 5 characteristics, or all 4 characteristics of a binomial distribution. Okay, so now let's go ahead and scroll down here and take a look at problem 2. Okay, so what they're doing here is they're messing with you a bit. They're giving you a percentage and they're trying to distract you into thinking that's P. So let's take a look at the question. We've got a random sample of 1,500 adults to ask if they support an increase in the state sales tax from 5 to 6%. Yeah, don't we wish? Ours is 8 3/4. Unless you go to La Mesa and it's 9.25%. Okay, let X denote the number in the sample that say they support the increase. Here's the value of P right here. Suppose that they tell us what the population proportion is. So the probability of success, P, is equal to 40%. N is equal to the 1,500 people they ask. The mean of X is just 1,500 times 0.4, which is going to be 600. So the answer to that is E. And the standard deviation, remember the standard deviation of a binomial random variable is n times p times 1 minus p, and take the square root of all of that. So if you do that on the calculator, you get D, which is, I had to check it with the calculator, so I paused it for a minute. Okay, so there's 1, 2, and 3. Let's take a look at question 4 now. Okay, so we're testing ESP. Experimenter looks at cards that are hidden from the subject. Each card has 4 different choices. Okay, so that means if you look at a card and you try and guess which pattern it is, you've got a 1 in 4 chance. So it looks like they're setting this up to have a probability of success of 0.25. We're looking at 100 cards, so n is equal to 100. Okay, what is the probability that the subject gets more than 30 correct if they're just guessing? So they're asking for the probability of more than 30. And remember what I told you to do. You make this diagram like this, 30, 31, and then we're going to dot, dot, dot up to 100. We're looking for greater than 30, so that's this group right here. So what we can do is find 1 minus the probability of X less than or equal to 30. And we can go ahead and figure out this probability and then subtract it from 1. And that we can use the binomial CDF with. So I'm going to go ahead and turn on my red so I can do this in red. So this is binom CDF of 100.25 and 30. And what we get with that is 0.1038. And so the answer to this is C. That's how you do that one. Slide that out of the way. Okay, college basketball player makes 5/6 of his free throws. Assuming free throw attempts are independent, the probability that he makes exactly 3 of his next 4 free throws is. Okay, this is the binomial formula, and that's the one that's in your formula sheet. We're looking at exactly 3 of his next 4. Probability of success is equal to 5/6. Pretty good. Okay, and if you look at the formula, what we're looking at is 6, choose 5, probability of success 5/6 to the fifth, or to the third, because we want to make 3 of our next 4, and the probability of failure to the first. Okay, 6 choose 5. Remember, this is not a fraction. Okay, 6 choose 5 is 6 factorial over 5 factorial times 1 factorial. And if you figure that out in your calculator, you end up with 6. So the correct answers, oops, I blew it. I think I will try and erase this and do that over again. Okay, let me do that one more time. For some reason I can't erase with this program, which is not cool. So let's just do that one more time. The problem is right here. I shouldn't have put 6 choose 5. It's actually 4 choose 3, because we're looking at 4 free throw attempts, and we make 3 of them. This part is correct. So the probability really should look like this. Equals 4 choose 3, 5/6 to the third times 1/6 to the first. There we go. So this is the number of attempts. This is the number of successes. 4 choose 3 is going to look like that, but that'll be a 4, this will be a 3. And so we're going to end up with 4 times 5/6 to the third times 1/6 to the first. And that's going to be, it looks like E. Okay, so 5 is choice E. Okay, problem 6 you can do 2 different ways. You can do it with the just the definition of a geometric distribution. If we're going to do this, do it where we have probability of success is 0.3 and probability of failure is 0.7. When x equals 4, what that means is you're getting the first success on the 4th trial, which means you failed, and then you succeeded. So you can look at the probabilities like this: 0.7 times 0.7 times 0.7 times 0.3. The probability of failing, and failing again, and failing a third time, and then succeeding. Probably the easiest way to figure it out. And if I do that on the calculator, I get 0.1029. 0.1029. So the answer here is going to be D. The other way you can do this is with the geometric PDF function on the calculator. So you can look at it this way, which is going to be, and on the calculator, geometric PDF of 0.3 and 4. And you'll get the same thing. You'll get 0.1029. So there's problem 6. Okay, problem 7. 7's easy. 7 is a geometric distribution. The expected number. Oh, expected. What do you think of when you see the word expected? Yep, average. So we're looking at the mean here. The mean number of free throws required until she makes her first is, well, mean is equal to 1 over p in a geometric distribution. So 1 over 0.8, and 1 over 0.8 is 1.25. So the answer here is equal to B. And the last question. Okay, this is the same, an ESP type question again. Okay, but now what's the probability it takes more than 4 trials? So we're looking at more than 4 trials. So that means 5 or more. Okay, so we're looking at like that, and this is a geometric distribution now. Okay, because we're looking for taking more than 4 before getting the first correct guess, or the first success. Okay, so this is more than 4. We're looking for this right here. Okay, and we can use the geometric PDF function. Equals 1 minus the probability x is less than or equal to 4, which is 1 minus, and I can put this on here, geometric, and we're going to use a CDF function now because we're looking at several of the numbers put together. CDF of, okay, 0.25 and a 4. And what we get with that is 0.316. And that answer is B. And there are the multiple choice questions.